Welcome all to today's ASRG World Webinar. We have the 27th of May 2021 and we are streaming from Stuttgart in Germany. Thank you for being with us. My name is Sven Schran and I am coordinating with ASRG the European locations. The Automotive Security Research Group is now nearly 4 years old and we are a non-profit organization which provides a platform for the automotive security industry as well as related academics or organizations to share knowledge, build powerful networks and valuable collaborations. This community is for you and it is based on volunteer support. If you want to know more details about ASRG, please check out our webpage at www.asrg.io. Send us your questions via email to hello@asrg.io or follow the links in the description below this video. Maybe you have an idea for a nice project and look for partners to realize it. You would like to start your own location, you have an idea about a service ASRG could provide to you, know a great organization which could partner with ASRG, or something similar. We are open to hear each idea you have in mind and would like to discuss how ASRG can support. Don't hesitate and get in touch with us. So, this is enough from my side today and I don't want to keep you tortured anymore because I am sure you are waiting very curious for our main presentation. Like every time, in case you have questions during the presentation, please write it in the chat window. After the session, we will have some more minutes for questions and answers. And now it's my pleasure to welcome Scott Cadzow, Director and Founder of Cadzow Communications Consulting. Today, he will bring to us the topic, the role of standards in motivating innovation in the ITS world. And now I would like to hand over to Scott. The virtual stage is yours.
Thank you. Thank you, Sven, indeed, for that welcoming presentation. As Sven has said, I'm involved in standards. As you can see on this opening slide, I'm chair of a number of groups in ETSI doing security standards. I'm rapporteur of a number of groups in ETSI also doing security standards. So that's the caveat I'm going to bring to this meeting or to this session, and we'll be talking about standards. So I'm going to open with some caveats and background. First of all, standards are a heaven for lovers of TLAs, three-letter acronyms, and there'll be lots in the presentation. You'll already have seen a lot of them just in my byline, which will somewhat come clearer. The other thing I'm going to ask you to do, if there are any that are not clear, use the chat line on YouTube to ask questions, and I'll try and cover them off. Some other points, standards and tertiary education really touch, and I'll want to address that, and it'll come back to it a few times, because my personal view is that standards are fundamental to development of large systems technology. The other thing that behind this is that standards should never be seen as a lowest common denominator. They should always drive development, and they ought to be difficult to achieve. And that's what I'm going to be talking about throughout this next 20, 30, 40, 50 minutes, however long it takes me to work through these slides. A couple more caveats. Transport is a global issue. We can't deny that. It's got an impact on everything. It's an impact on the environment. Obviously, I want to keep living here on this globe, in this world. So that impacts me. It impacts health and safety. I run a bike, I drive, and all of them should be able to do safely. So whether I run, whether I bike, whether I drive, whether I walk around, whether I take public transport, all of them should be safe for modes of transport. It impacts technology. I'm ultimately a technologist, and ultimately affects society and politics, and we cannot avoid that. And I'll come throughout this presentation, throughout this webinar, we'll talk about things dealing with society and politics, and ideally transport's equitable. So equity in transport provision is actually quite difficult to do. The picture you can see on the side shows two views. I mean, the traditional views is we try and achieve equality. Equality doesn't mean give everyone the same provision. What we want to do is give everyone a balanced provision so they can do the right things. So We want to try and achieve equity in transport provision. It's politically very difficult. It's a challenge for technologists and for R&D, but it's something that I'll be touching on throughout this presentation as something we have to try and achieve. Otherwise, we're not serving the people who require transport. So I guess a lot of you will have seen this picture over the last 10, 15 years. It's the root picture for a lot of the ITS work we've been doing in the last 10 or 15 years. And this comes from ETSI as part of our Standards on the Move initiative. And what we were trying to do was develop ITS with a view to integrating all these different types of systems, safety systems, vehicle-to-vehicle systems, fleet management, navigation, traffic signals, traffic signage, trip planning, parking planning, all those things were brought together as part of our original vision of what ITS is all about. And one of the concerns I have is we've addressed only very small parts of this, and we need to address all of this over time. So one of the problems here is that although this picture drives or ought to drive new models of innovation, we don't always see that innovation. We often see quite a lot of reluctance to bring these systems together. And when we first drew this picture, we didn't have some of the technologies that are illustrated, and we still don't have a lot of them working together in a way that actually aids transport. And one of the things I'll try and talk about during this presentation is how do we bring these kind of things together to work to achieve what this picture presents as our goal. So why do we need intelligent transport? Essentially, this is fairly straightforward. Transport means getting people, goods and services to where they're needed on time without damage. Ultimately, though, transport is not vehicular. It's not about vehicles. It's about people. It's about getting people to work, to play, to school, to family, to live their lives, basically. And it's getting things to people that they need to do that, that need to work, to play, to learn. Therefore, transport fits into society, not the other way around. We shouldn't be fitting society around transport, although we end up doing that. And we've been seeing that with some of the urbanization of society in the past few decades. And we build cities for cars and not necessarily cities for people. And that's something we need to think about as we move forward in intelligent transport. And the variables in making transport work are large in number. They don't really work together by magic. And we need to apply logic and intelligence to make transport systems work for us. And that's something, again, I hope to come back to and refresh and elaborate upon during the presentation. In terms of standards, though, standards are things that we do to give us both capability and functionality. So we need capability, which is the power ability to do something, and we need functionality, that actually doing it well. So when we've been developing standards in things like ITS security, we address capability first, which gives the system the ability to do something that it needs to do. And then we maximize that functionality in order to do that thing well. And we develop security standards primarily to address risk, to limit the freedom of adversaries to break the system. So basically look at what are the bad guys going to do to our system? What do we do to prevent those bad guys breaking our system? And so we start with that capability view in order to find out what capabilities we need to add to the system. And then we provide the rationale for that. Then we end up over time maximizing the functionality so they actually work best for us. And so the role of security standards in general are in two parts. There's a core system protection role. So with the CIA role, trying to protect confidentiality and integrity, availability of the system, and we need some analytic data for that. So we need to forecast, resolve, recover from attacks against this system itself. We also need to look at an anti-adversarial role, so we can identify who gains from system breaches. That's the role of the threat analysis work we have to do. And that needs intelligence, that needs data. So we need to be able to make sure our system works to protect ourselves, but also protects ourselves by identifying who our adversaries are, so we can work against the adversaries as well. And that means we need to look at risk management, and we need to look at regulatory compliance. We need to make sure we do things properly as well. We can't take on the tools of the bad guys to protect ourselves. We have to take on tools that aid us as good guys to achieve these things. So we have to comply to things like GDPR, the Cybersecurity Directive. we have to look at ensuring that law enforcement can do its job. So there's a number of problems in ITS that I've seen. I think we need to go a bit further on. Certainly we've just designed in capability and functionality to achieve something, but we're not really on the same page with what we want to achieve. And that's because of the set of stakeholders. All the industries we need to come together aren't really come together. We're not really getting the smart city industry coming together. Not really getting the rail industry and the road industry coming together. We're not really getting the vehicle manufacturers together with the electricity generators, for example, for EVs. But we need to bring them together. And in some cases they are, but we need to make sure we're doing the right thing by bringing more people together. And in some respects, we're digging ourselves into holes, providing security functions for what we know and what's possible today, but we are not necessarily solving the problem that actually exists. We're solving a problem we've been given, but there are problems we're actually actively avoiding because we're limiting our scope. And I'll come on and talk about that as well. The other thing we are doing in ITS, we talk about cooperative intelligent transport systems, but we are often not providing cooperative intelligent transport systems or providing systems that allow them to be seeded, but we're not designing the long-term systems. So one of my concerns is that CITS requires cooperation, cooperation requires dialogue, dialogue requires message exchange between known parties, intelligence requires learning and vision, transport needs qualification. There's a whole set of things we're not quite ready to do yet, and things we need to basically reinvigorate within the industry to get these things to work. So humans are also problematic. This is something I tend to discuss quite a lot around where I live, in that I have some interesting people around who look at selfishness and altruism and various other things. But in an ideal world, we should always act altruistically as individuals, as societies. And that really means having a disinterested and selfless concern for the well-being of others. Really, in ideal systems, again, the transport system should always be altruistic or altruistic by default and equitable too. In other words, it should be available to all and on an equal basis. But in the real world, we tend to act really selfishly. One of my bugbears of driving and cycling and running and stuff is that people are just selfish. They hog traffic lanes, they harass other road users. They seem to have this idea, it's my car, my privilege, my ability. It becomes quite selfish rather than altruistic. We don't work together well enough. And our mode of transport seems to change our personality. People get into cars and suddenly go from being nice, gentle, well-loving people into selfish road hogs. And we need to work with that as well. And our transport has to cover everyone. It has to cover all forms of transport. And the list of pictures at the bottom has to affect everyone from birth to death, whether they're walking, whether they're working, whether they're if it's an emergency, whether they're able or disabled. They have to be able to use the system. And our system has to be human-centric and society-centric, not device-centric or not vehicle-centric. So what we're going to look at in terms of ITS security is, what are we securing in transport? What are we really trying to do? And I'll talk about trust as we come all through this, but essentially we're trying to make sure the system acts on trusted data. So when we get data from a vehicle, is it really from the vehicle? If we get data from the transport network, whether it be the roadway or a rail network or a tram network, is the data it's giving us trustworthy? Is it something we can rely upon and act upon in an honorable way? So does the system give us trusted data, and does it act in a trusted way? So we need to identify who we trust, how we validate that trust, and what do we do if we're not sure? And that's a problem that we tend to have, in the past 80 or 90 years of using vehicles, we tend to not be trustworthy of other users. So we tend to become selfish. So you go back to this picture that we, in the real world, we tend to act selfishly because our trust tends to focus on ourselves. We trust our own ability in driving the car, not the others around us. We trust our own ability to make routing decisions for ourselves and not those of others. And we need to try and break that cycle so we can actually get ourselves trusting more and more people in the system, and therefore the system acting as a better set of trust for making decisions for transport and for our movement. So if we're looking about intelligence in transport, and this is again something I've been looking at for some time now, how do we actually make intelligence in transport? One of the issues is that at the moment drivers tend to control vehicles. Human beings make lots and lots of bad decisions. So can we design that bad decision making out of the system? And this is something we're going to have to look at as we more to autonomous vehicles and then into autonomous transport systems. So one's multimodal. How do we ensure that the decision making is always good or always better? And also, transport is one of the biggest critical infrastructure we have. We can't afford it to make bad decisions. We can't afford, as society and as societal users, for transport to break down. We can't leave it without control to manage itself. We need to be able to bring proper intelligence to transport, and that raises its own major concerns, which I'll come on to hopefully. So intelligent use of transport is an important consideration. Transport doesn't stand alone. And this is getting back to one of the early statements I made. Transport is societal. Transport is about people. So it has to interact with people. It has to interact with commerce using logistics plans. It has to interact with industry. So if industry is setting up a just-in-time manufacturing process, it has to make sure that logistics work, that the people work, that the goods and services get together. And a lot of that is dependent upon our transport networks. But our transport networks are there to serve the industry, there to serve the people, there to serve the commercial systems behind it. And that needs intelligence. So the intelligence isn't about the vehicle, the challenge is about the system. And that's an important consideration that we're not always making in the work we're doing. For some, most applications, well, let's rephrase that. For most applications of intelligence, we need data and we need to learn. The growing meme of today, or the growing idea of today, is that everything's going to be artificial intelligence driven, machine intelligence driven. So we're going to have autonomous vehicles, so the intelligence lies directly in the vehicle. We're going to have intelligent smart cities that route us automatically where we want to go. In order to do that, we need to bring data into the system, and we need that data from lots and lots of sources. We get the data from the driver, we get the data from the message the vehicle is sending out. In CITS vehicles, that means the CAM and the DEN messages. We get data from the environment, including CITS data, but also the weather data, the day of the week. We need to know whether there's a major football match going on that day in that locale, because that impacts how we route people around transport. We need to know if the weather's bad, do we lower the speed limits? Do we raise the speed limits if the weather's really good? Do we lower the speed limits if there's congestion? All those things we get data from, and we get data therefore from all the stakeholders. And the great thing about transport is there are no excluded stakeholders. Everybody in society is a stakeholder in transport, because at some point they need transport services to get them from A to B, or get something they want into their house or into their hands. But one of the questions we've got to ask ourselves in the standards world and the technical world, are we building the foundation of intelligent transport systems, or are we just building smarter vehicles? And do smarter vehicles make for better transport systems? Those are kind of hanging questions. My answer you could probably guess, but I'll hopefully expand on that in a bit. But smarter vehicles of themselves don't make better transport systems. Better transport systems may make for a better application of smarter vehicles. So intelligent transport systems, we need to think of this as a system. One of the things that I kind of get annoyed about over the past few years is we tend to talk about intelligent transport systems in very close contexts. We tend to think of them as vehicle-specific contexts or smart highway-specific contexts, not as big systems. And the problem with that is that if you're doing it properly, finding that boundary is difficult. What we're doing at the moment is we tend to cut the scope of the system, and that actually allows us to do the job that we're asked to do, because we cut the scope of the system to make the job achievable. But that excludes the city, often excludes the environment. It tends to silo the applications. which is contrary to good, well-driven, well-designed intelligent transport systems. So we actually need to expand our boundary, and expanding our boundary is going to take time and effort, and we need to be prepared to stop cutting the scope of the system to make the job easier. So what is the ideal system size? Well, it depends where you are, but it's certainly seen by some people as a single vehicle, some as a single bus route or a single just-in-time logistics plan. But ideally, you want to bigger than that. You want to cover your village, your town, your country, hopefully your entire region. So within Europe, I'd certainly be delighted if I could have an intelligent transport system that takes me from this, where I'm sitting as a non-EU country, but right across. I could drive out of England, where I'm sitting now, into France, across France into Italy, and then from there through Slovenia and all the other countries to take a long European tour with the same system in place, and not just rely upon the systems in my vehicle, but ensure the system in my vehicle can actually work with the systems across the EU and ultimately across the world as well. So we look at intelligent cars. Intelligent cars is quite nice. It's quite a well-defined environment and boundary. There are a set of well-understood subsystems that we can use intelligence to improve. We can use technology to improve. So we can improve the suspension, we can improve the drivetrain, we can improve the cabin environment. And there's a clearly understood beneficiary. It's essentially the driver or the vendor manufacturer, the sales guy. They're the guys that are going to benefit from these well-understood, nicely improved subsystems. So you got a better drivetrain, you got better suspension, better cabin environment, you're better than competitor. Therefore, you can sell the car to the driver. The driver has a nice environment to sit in, but it doesn't actually make their car any better within the transport system because it's still an isolated system. So you can improve the car. We can add intelligence and more technology into things like the suspension. So you can have adaptive and reactive suspension, which will give you more grip, more feel, more security. It will just feel safer and better to drive. You'll have a more economic drivetrain because you can optimize fuel use second by second. We're a long way from the years of using carburetors, which just flung in more and more fuel. If you put the accelerator down, now we have metered fuel. You can drive incredibly quickly using very little fuel. You get adaptive air conditioning in the cabin, so your air conditioning keeps you more awake all the time. You get a much better environment to sit in whilst you're driving, and obviously the drivetrain will be better for you, so you'll be using it more often. You'll have better suspension, so you'll be able to drive as badly as you want in whatever conditions that the weather happens to throw at you. And again, there's a clearly understood beneficiary. The driver's the beneficiary of this. It doesn't benefit hugely the pedestrian side of the road. It doesn't really benefit the road surface very much, maybe a little. But ultimately, the beneficiary is the driver or the vendor, the guy that's actually selling the cars. So the more technology, the more intelligence you can put into a car, the more likely you are to sell that car against the competitor who hasn't put those capabilities into the car. But it's not really intelligence. Again, intelligent cars, you've got showroom attractiveness. Again, it's more gizmos than money, more gizmos than the competition. So you get somebody walking into your showroom, they see your nice, shiny, fancy car, and they're prepared to part with their money to get a hold of that because it's nice, it's got all the gizmos. But again, it's not part of the system. And again, the understood beneficiary is the driver, the purchaser, the person you're selling the car to, the person that's buying the car. And ultimately, that gives back some real benefit to the vendor, to the manufacturer, in it they can use the intelligence to increase showroom attractiveness and therefore sell more cars. But intelligence for transport is much more complicated than that because it connects people and things to disparate and separated resources. So we need to connect home to work, we need to connect factory to showroom, shop to consumer, sports fan to a game or an event, or music fan to a game or an event, a pupil to school, student to college. All these things are what transport's for. Transport's not about cars. Transport's not about having the best push bike in the world, although I quite like one. It's about making all those things work together. So it's multiple modes working together. Buses, trains, trams, bikes, foot, that's pedestrians, cars, lorries, vans, all of those have to work together. And the beneficiary changes. The beneficiaries now, if we're looking at intelligence for transport, the beneficiary changes to society. It's a much bigger entity than having to supply or satisfy a single individual or a single manufacturer. We're now having to satisfy a much bigger entity, which is our society. So that means we need to bring in intelligence across that capability. We have to look at much more than just vehicles and doing intelligent transport. We have to look at things like smart cities, enabling more efficient transport and enabling better parking, better transfer of people around cities. It means maybe less reliance on individuals having their own cars, but by bringing them together with public transport, with mass transit in general, or even making better uses of Uber, so you don't need to all have your own car, you share things essentially. We're looking at smart ports where we tie in logistics with transport. Getting in at a port has both local and non-local impact. So if you're taking a very large container ship and it's docking at a major port like Rotterdam or Harwich in the UK, then you have to get all those containers off. You put them in lorries. That's tens of thousands of lorries potentially moving out the port and onto a set of local roads. So in the UK, Harwich has got fairly small roads coming out of it. They then feed out across the rest of the country. That's got a huge both local and non-local impact because you're having to send people all into central places. But if you can do it better, you can actually make these smart ports work, these smart cities work. Again, you get a much better, or the beneficiary becomes society. So the beneficiary becomes much bigger than any individual. We can actually make transport more efficient by working with our cities, with our smart ports, with our societies to make the society the beneficiary of intelligence transport. There's a number of existential threats depending where you stand. Vehicles are not the only game in town. And I keep on having to come back to this. Transport is not about vehicles. Transport is about getting things from A to B, whether that's a person or a set of goods, set of anything, money, whatever. Autonomous vehicles are going to come. They're non-human controlled vehicles. Can we serve intelligent networks to serve them and save us from them? Intelligent vehicles, that's a bit of a misnomer at the moment. They're certainly single point intelligence, but they're not general intelligent. They may not be able to recognize all the things we recognize naturally as humans, but we'll build into that. But do we have to rebuild our transport systems to allow non-human controlled vehicles to work well in it? Electric vehicles are going to come. That means drivetrains are changing. Does this impact ITS? Is there an impact that we have to address? So how do we integrate ITS into our vehicles, intelligent vehicles that know they need charging, into the charging infrastructure, into the power system, into the smart cities who can actually find somewhere where there's a charging point? All these things have to be considered, and that means bringing in more and more stakeholders. We also have to recognize that car sales in certain demographics are slowing. Car ownership is becoming much less important to certain demographics. We need to know why. We need to know how to build. We need to know why in order to build mitigation and exploitation strategies. If car sales are slowing, but people are still needing to transport themselves from A to B, we need to be able to build the transport networks that suit them if they're not having their own car and if they're not definitely just cadging off their parents. If you're a parent, you know that issue of always having your children want to be driven everywhere. They avoid car ownership because they do it by proxy. We need to look at ways of doing that as well, building those kind of demographics into our system. So how do we get standards into the mix, and what's the role of standards in this? And I'll try and put forward some proposals, some thoughts here as well. So one of the things is about innovation leadership. So where we want to ask a number of questions like who leads innovation in ICT? What leads innovation in ICT? Where's the innovation in transport and who leads that innovation in transport? Because answering these questions will actually lead us to find stakeholders that make our transport systems in general more suited to the purpose, which is bettering society, bettering our capabilities of giving equitable access to transport in society. So what leads innovation? Yeah, a few things: science, innovation, or science, education, money. Very occasionally government lead it, but essentially we need science to be developed to find new things out. We need people educated to make use of that science. We need money to back it so we can actually develop the science into products and services. Occasionally government does this. They did it very well with things like the GSM and cellular radio. And they directed us how to use, or what we are allowed to use radio bands for. We had to develop as technologists specific technologies to allow us to use that. And we were given fairly strict instructions of how to do that, but we were given also a fairly free hand in innovation of how we achieve that. And you look at the success of that is phenomenal. There are 7 billion users of cell phones on the planet. There are 7 billion, or slightly less than 7 billion people. There's over a phone per person in the world. And that's just by government decree, essentially saying you shall build a cellular radio network, and you shall do it as quickly as possible, and you should use as much innovation as you possibly can. And we're also doing other things now with things like the EU Cybersecurity Act, the Radio Equipment Directive, GDPR, which has made a huge focus on how we develop models that allow reasonable use of data with protecting the individual from exploitation of that data. And that will actually lead to innovation in ICT in how we develop systems. So again, not just what leads innovation, but who leads innovation. Government, I've suggested, already does that. It occasionally makes big innovations. Education sector has a huge impact on innovation, largely through the research programs. So basically post-tertiary education into the higher MSc, PhD type programs. Industry does a lot of innovation. We can't forget that, often through competitive R&D, and individual entrepreneurs and inventors lead innovation, often through startups and, I'm going to say, hacks. They find something that they need to do. They bring together some existing technologies, modify sufficiently to make it innovative, and hack it together. And then from that, we can actually develop new products and new services. And they're building on the knowledge they have from science and from education to build those things together. But together, we've got a whole bunch of groups involved in innovation in ICT in general. But once we look at innovation in transport, I'm kind of skeptical. But then I'm a cynic. So transport innovation is mostly, in my view, kind of evolutionary, with a few revolutionary steps. So we had passenger rail was developed in the 1820s. Up until then, we'd been using stagecoaches and horses and stuff, and Shanks Pony or pedestrian-led traffic is going around. The safety bike was invented in the 1880s. Brakes weren't invented until the 1890s, I don't think, so kind of important. Motorized vehicles came around in the 1880s. Commercial passenger traffic, passenger carrying aircraft in the 1910s, 1920s. We had passenger carrying hovercraft in the 1960s. We still have in the UK an active hovercraft link linking the south of England with Isle of Wight. Carries several hundred people every day in a hovercraft. And we've had micromobility brought in fairly recently in 2010s, 2020s. With, you can see e-scooters everywhere. But a lot of those are innovations. The fact they've gone from early electric cars through petrol cars and all the rest, they're refinements. They're not revolutionary, in my view. You know, the fact that a motorized vehicle existed in the 1880s, you can look at a car from today, like you look at the latest from Ford or BMW or Tesla, and compare that to Benz's original or the Stanley car, and they are recognizably both cars. You look at an aircraft from the 1920s, 1930s, look at an aircraft today, they're recognizably much the same thing. Rail transport, really, it's much the same. We have something at the front that drags it along, and we have people sitting in carriages. And even my latest, 10, 11 speed, 22 speed racing bike looks not that different from a safety bike that was invented in the 1880s. So we've got a lot of evolution, not a lot of revolution, and we're seeing more and more evolution, with possibly the biggest revolution being the application of more and more ICT and connectivity to transport in a way that's not transport related. And I'll talk about that in a minute. But essentially what that means, if you look at the global road network, the road network connects everybody and everything together eventually. The same can be said for the telecoms network, the telephone network. It joins everyone together through a virtualized network, through pieces of copper everywhere, pieces of copper and fiber, as opposed to concrete and tarmac. But as we're seeing now, we're seeing things like smart highways, we're seeing smart roads, we're seeing smart cities, and that will bring in new innovation systems, because we're going to move away from transport being just vehicle type towards transport being systems of transport, systems of using forms of vehicle. So who leads innovation in transport? That's more difficult than even in ICT, which is difficult as it is. National transport policy plays a role. Environmental policies play a role. Individual modes of transport tend to follow the pattern of ICT. There's a lot of evolution, not a huge amount of revolution. But certainly environmental protection is huge. A national transport policy that determines things like the size of the road, the size of the speed that cars are allowed to drive in roads, where they're allowed to go. All those things have a role in innovation, and we fit into those kind of goals and systems. But standards bodies can also be innovation leaders, and I think this is what I'm going to spend the next few slides, since the last few slides of this webinar, talking about. Standards bodies are innovation leaders because we bring in talent and we cross a huge number of fields. So the bigger bodies, people like ISO, the International Standards Organization, ETSI, which is the European Standards Organization alongside CEN and CENELEC, they are hotbeds of talent. They bring in knowledge of radio, of switching, of all sorts of software, hardware, technology, of how human users bring into systems. They can bring in innovation because they can bring big systems together. So bodies such as ETSI or ISO can bring together experts that consider big systems of transport. They can look beyond just the vehicle. They can look at how the ICT backbone will assist vehicular transport, how they will assist societal use of transport. So those realities, the ICT backbone, the mechanical building of machines, the smart infrastructure, they can all be brought to use the right machine at the right time into transport. So transport can benefit from ICT, ICT can benefit from transport. We can look to build them together. Then we look down to policymakers that can lay down forward-looking targets as policy, which you can then pass into standards. So emissions controls, safety devices, passive, active, cooperative systems, safety systems, system and societal integration, equitable access, they can all be set as policy elements that we can then use our innovative skills in technology and develop solutions that actually allow us to meet those requirements set down by the challenge of making transport for society. So setting challenges is pretty important. Engineers or standard makers tend to react well because we're generally engineers to challenges. Set us a challenge and we'll quite willingly go away and find something to fix it or solve the problem. But we need fairly simple statements of policy, and often simple statements of policy are very far-reaching impact. So I've talked already about GSM, or GSM, but digital cell phones were only allowed to access the 900 meg band in the late 80s, early 70s, late 70s, early 80s, right through the 90s. And essentially we were developing cellular systems for a long time. But that development was led by a fairly simple policy decision in the EU, as it was then, or EC as it was then. And that turned into GSM, which turned into 3G, 4G, now onto 5G, and we're looking beyond that in the future. But we now expect to be able to connect it anywhere, anytime through our cellular phone networks. When we introduced the requirement to have passenger restraint systems, essentially seatbelts. That led to a massive improvement in structural integrity of cars, because if you stuck a seatbelt on a 1940s car and you crashed, the seatbelt wouldn't really have done very much for you, because the car would have fallen apart anyway. So we had to build more structurally more sound cars in order to make sure the seatbelt system kept us in the seat, rather than allowing us to be kept in the seat but outside the car somewhere. Now, we have all sorts of changes because of that one requirement. Have a seatbelt system or a passenger restraint system, and that changes how you build cars. We also had massive changes by taxation based on CO2 emissions. The various fuel and oil prices encouraged ever more efficient engines. And if that is, as that get more and more tight and tightened even further, so you have to have less and less CO2 emissions across your fleet, you end up having to go towards building EVs. If you're building EVs, you've then got to integrate into the electricity network. If you're building into the electricity network, you might want to build into other parts of the ICT network. And we can see examples of where innovation has allowed people to redesign cars on the fly. Tesla, for example, redesign the functionality of their car through software download quite often. And so you see that innovation occurring throughout the fleet and throughout the system. So who knows about standards? And this is one of my bugbears. The people that really know about standards are the standards development organizations, and not many other people, unfortunately. Some governments, they take that definition of a required agreed level of quality or attainment, and they often use that as the basis of regulation. So you see standards in a lot of policies, water quality, food quality standards, agricultural standards, animal welfare standards. We rarely see them in general life. We tend to see them more in regulation, but they enforce government through measurement, tests, and legal system to make sure you comply to the standard. Some industries are really good in standards. Connected industries, I would say, are very good in standards. That's the telecoms industry in particular. But also those with very complex supply chains tend to be good in standards. Some aren't. Some educators are really good in standards and know about standards, but they are often contingent in knowing about, or the requirement to know about standards is contingent upon granting, how they're given money. And often citation is a barrier to educators or students actually getting directly involved in standards, because your standard often is published anonymously by the standards body. So in ETSI, the standard is published by ETSI. It's not authored by a rapporteur or by contributors. So it's very difficult to cite your contribution to standard in your PhD thesis, for example. And that's an issue in education we have to look at. And we are looking at that. And we've developed new mechanisms in standards bodies. In SEN, look at the cooperative workshop agreement that allows you to be cited directly as an author. In ETSI, we have the industry specification group, allows you to be directly cited as an author. And that eases the ability of educators in the education system to work with standards. So what should society's transport goals be, and how do we use that? How can we do this with standards? Obviously, one of the goals I think should be substantial reduction in transport-related death and injury. That seems kind of obvious. Substantial reduction in transport-related environmental cost. That means we also have to look at how we use transport. We don't always have to have powered vehicles as a priority. We can also make technology, or allow technology to assist us in making choices that are more obvious and accessible for the means of transport. So connected transport, including connected vehicles, allow us to use the most effective vehicle type for the transport need at the time. So don't use a huge truck when you can get around with a small, electrically powered, carrier bag or something. So we need to think about the whole last mile logistics issues have to be brought into bear, and we can use technology to prove that. We also have to do a massive improvement in equitable access to transport. Transport is still an economic divisor in society. We have to bring some thought to that in bringing this complex mix of economic, social mobility, societal growth, and technology together to achieve better transport systems and better access to those transport systems. And that means better use of, in my view, standards. So how do we use standards to score goals? Well, We can use that. We can set the barriers or the bar as high as we can. So required degree level of quality attainment should be set as high as possible. So zero emissions at point of delivery is possible. That leads on to things like having EVs, zero emissions across the entire society supply chain might be a target, but we can also address that in different ways. So one EV delivering groceries to 100 homes is more environmentally sound than 100 vehicles using diesel engines from 100 homes driving to and from the supermarket. We can build that into our transport system or transport requirement. So we can, if you're having to put into, every time you switch on your engine, you're seeing how far you go, your car can say, really, on your bike or go take a walk, don't use your car for that journey. And we need to build that not just into the technology, but into our societal understanding of transport. We also have to think about always connected transport and societal infrastructure. We cannot separate transport and society. So transport binds society, and society is bound by our ability to travel for work and play and family life. So we need to connect transport to societal goals, and that requires connectivity and data and intelligence to bring it all together. All of things we can build standards for at the highest level of attainment to try and get there. We also need to look at extending the players in standards. If we're seeking altruism and minimizing selfishness, then achieving and defining that higher level of quality of attainment requires more players in the game. So we should bringing in more and more educators seeing about the role of standards. It's not just to teach them technology of things like, how a GSM phone works or how an ECDSA signature algorithm works, but tell them why it's there, work through why we want to make that public and accessible, and essentially teach them about the role of development standards as part of the role of developing technologies. Entrepreneurs, we need revolutionaries, but we also need to drive evolution and improvement, and we need to serve our community. So ensuring that we can bring entrepreneurs into this system, giving them connectivity, interoperability, and interconnectivity, all things we need to give assurance of. We need to make sure entrepreneurs take that on board. And also governments have to encourage altruism and discourage selfishness in society, and do that at the same time for themselves, which is something that not all politicians tend to do. So I'm going to come to the close. Just a few slides to wrap up. A sort of summary and conclusion I want to give now. So what are transport systems? In summary, they're a societal imperative. We need transport systems to make society work and to allow societies to develop, grow, and flourish. They're also a technological opportunity, not vehicles, but systems of movement for all stakeholders. So we need to work society and technology together to make transport systems work. So what are standards in this case? Well, standards as defined are this required or level quality or attainment, but they have to be set high enough to give technical drivers to the developer standards. They have to be exciting in that terms of attainment. They have to be difficult to do, and they have to be able to achieve interoperability and interconnectivity. And by achieving that, we open up the market to multiple players. We're not leaving our world in a set of proprietary dead ends. So I will be able to take a component from widget A and work it alongside a component in widget B, in the same way that it's not that easy to change wheels between cars. It's relatively easy on push bikes, relatively difficult on cars. It's very difficult to change gearboxes from one car to another. We want to be able to develop that kind of level of interoperability and interconnectivity so we can actually get transport, not vehicles, as the core of our attainment. So why standards to drive innovation? I'm hoping that you've picked up that I'm keen on standards. Standards drive innovation because it allows multiple stakeholders to drive complex markets. It allows consequences to be discovered and driven out because you get more and more stakeholders looking at the problem, working through the problem themselves, finding solutions that are useful to all. To quote Donald Rumsfeld, the US politician, he had this long phrase about known unknowns and non-unknowns and all the rest. But what we need to do is maximize our known knowns, and that means getting more people into the system, drive away our unknown unknowns. More players from more backgrounds drives us to maximize the benefit of the technology we develop. And standards are almost always altruistic in that they benefit more than one stakeholder. And that's what they're there for. They're to benefit lots of people together by ensuring that capability. So that's all I wanted to say. So thank you for listening. I'll take any questions through Sven as we come to an end. So thank you for your time.
Okay, so at first, thank you also from my side for give us this overview and also for your personal opinions and experience you shared. Let's start with the questions. The first question would be also regarding your experience. If you look in the real world today or in the reality, what do you think where we stand with ITS systems? Or in other words, are we only in an experimental phase at the moment and it needs more or less more 10 years if we can see such systems in our cities, for example? Or do you think we are just some steps more?
Unfortunately, I think we're still at the experimental phase, and we've been at experimental phase for far too long, because it's expensive to put in. And there's a certain chicken egg kind of problem. Do you put in ITS systems into cars, or do you put ITS systems into infrastructure? There's no benefit if you're the only manufacturer on the ground putting in ITS systems, because all you're ever going to cooperate with is other cars of your own, from your own factory. But if you leave it to this system, then who's paying for that? There's a revenue generation issue. So there's a number of issues we need to resolve. The technology is there once we decide how to go forward. My gut feel is that the 5G operations in our 5G telecoms networks will actually have a huge benefit to intelligent transport, and they'll wrap over. And some of the discussions we've had, or arguments we've had in the past few years about ITS G5 versus V2X LTE will kind of disappear as we get more and more 5G networks. And then we'll be looking at different means of providing the capability. And then that will add in the existing well-designed CITS systems to make it all work. So there's a bit of experimentation still to do, but also to get the infrastructure side, we need to resolve and get people to resolve the financing and the not just the financing, but the revenue generation model. Nobody gives anything away for free. We need to encourage ways of finding it to give it for free, because you don't want to spend hundreds of pounds or hundreds of euros extra every year running your car just because it has to be connected. So that's something we need to look at, and that's why we need to get more stakeholders involved and not just the vehicle guys.
Okay, yeah, thanks for this answer as well. There is at first an opinion from a participant from the webinar today, and afterwards it comes to the question about your personal opinion as well. So ITS should mainly provide better information in due time to the people such that they can improve their behavior. ITS should not introduce or enable robots as that may convert freemen into slaves. What's your opinion about liberty and subsidiarity?
I'm yeah, I'm a libertarian. I don't, it's a good question, actually, a good comment. I've been spending a lot of time discussing matters of ethics and artificial intelligence and robotization of our world. And we shouldn't be robotizing our world. We should be serving ourselves. And that's why I talk about, and that's why I spend a lot of time talking about altruism. We've got to move away from selfishness and get the system to work for us and not to become slaves of the system. And that's difficult. That requires quite a lot of time, care, education, thinking, but it's a brilliant goal. If we can get to the point where we actually can use technology for our benefit, not for the benefit of the manufacturer of the technology, although they will benefit from it, and not to become slaves to the technology, but use it to enhance our lives. That's what you're doing in ITS. And I think I've made this point a number of times. Transport's not there for vehicles. Transport's there for us to use other things. It's for me to get to a football match or to go and watch the Grand Prix, which is cars running around the circuit, must be said. But it's for me to go and enjoy myself, me to go and do work, me to go and meet and play with my family. It's not about cars, it's not about vehicles, it's about societies and how we work together. And if we can use that better, we shouldn't become slaves to the machine. It shouldn't be, we should not have that. We need to become libertarians and use technology to liberate us. And at the moment, we need more people to take that stance and drive the technology that way. And if we can, that'd be great. Thank you.
Okay. Thanks for sharing your opinion about that as well. So the next question is, if you think about an ITS, it consists of a lot of components, the communication network, for example, back-end servers, IT technology, the cars you mentioned, infrastructure components. If we think about security, is there one part which needs to be, from your opinion, more taken care about security topics, or is it more or less all components on the same level, which needs to be protected somehow?
You can't take you can't strengthen one part of the system without weakening another part, essentially. So you've got to build strength across the entire system. It's like being an athlete. You can't just build up one muscle group, because what you'll end up is injuring everything else, because your weaker muscles will detract from your overall performance. You've got to build your entire body to be the right strength. And you have to do the same for ITS. We have to build in strengthened infrastructure. That means security infrastructure. We've got to build security at the radio network. We've got to build security in the core data provisioning system. So the core in-vehicle systems, the vehicle-to-vehicle systems, the vehicle-to-infrastructure systems, the infrastructure sharing systems. We have to apply security across it all. We've got to take a much more holistic view of approaching security. And I pointed out in one of the earlier slides where I said that the problem is we are tending in security, because we're only human, we tend to deal with the problems we're put in front of us, and we tend to sometimes ignore the big problems. And what we need to think about when we're talking about transport systems, not just vehicle systems, or not just about isolated communication systems, we have to think the big picture, and that means taking a much more broad view to make sure that there are no weaknesses that people can attack. We need to strengthen everything, and that takes time, takes effort. It is not a one-man job. It's a systemic job. We have to bring more and more stakeholders together. So we can't suddenly say, oh, we've forgotten off the smart city group. How do we get those involved and apply the wrong technology to their solution because we just have that technology lying around? We've got to bring them in as stakeholders from the start and then build it through to make it work together. I hope that answers the question.
Yeah, thanks. Do you have a recommendation for someone who wants to have a look in the field of standards with respect to security, where he can start?
Yeah, that's a good question. I would just recommend logging into the ETSI websites, the ITF websites, the NIST websites, reading up material, and talking to people, actually talking to the experts in the field, where the experts in the field tend to be very, I won't say outgoing, but if you ask them a question, they'll talk to you. So talk to experts, talk to people, and that's the best way to learn. Ask questions, ask any question, and we'll answer it. We tend not to be overly dismissive. We tend to be much more supportive than you would think. We are security experts, but we are not inhuman. We're not something for robots. We will answer real questions and encourage everyone to come. So anyone who wants involved in security standards, talk to the security experts. I'm one of them, I think. Talk to me. I'll encourage you, I'll introduce you to other people, and then just talk, get involved, write things, play.
Okay. The next question is, how can we solve the problem of competing SDOs, or can this not be solved?
I'd love to be able to resolve that. Competing SDOs are they're a fact of life. It's because they're competing industries, or competing vendors in the same market. What we need to do is get them to cooperate and use their expertise appropriately. We've already done incredibly well between CEN, ISO, and ETSI in the ITS domain. We are reaching out to get really good harmonization between ETSI, IEEE, ISO on the use of technology from IEEE. So we're using Wi-Fi type technologies. We're using 1609.2 technologies for signing things. So we are sharing technology. One of the underlying issues, which is probably not always obvious, there's a lot of IPR issues, or licensing issues. There's a lot of not invented here syndrome, which we need to resolve. That we can only do by sitting down together, and we are beginning to do that. We within the European standards groups, we have a European Standards Cooperation Group where we meet and discuss and try not to overlap on standards. But ultimately, the successful it's like any industry. Any industry will stand or fail based on its success. So good standards will mean your SDO's success, and SDOs are competing together. So we need to respect the competition, but we need to also respect that they have to cooperate. And so the same rationale for standards being altruistic to the users of them, standards developers should also be altruistic to make sure they work together to serve the wider public and use their expertise in the most appropriate way possible. So I hope that answers it. But yeah, there will be competition. We can't resolve overnight, but we need to accept it as a goal and attempt to resolve it and make us non-competitive, but cooperative and collaborative.
Okay, thanks. So let us come to the last question for today. Enabling standards like 802.11 versus blueprints, is this ensuring interoperability?
It does, to an extent. I mean, what we do is we need to bring in more publicly available standards. So IEEE 802.11 is a fairly open standard. You have to pay for it. That's true. But it's been well received. It's been well documented. It's been well reviewed. And because of that, it has impetus in the market. There's a lot of people paying the small amount of money for it. We need to keep that momentum going. We need to encourage more freely available standards. But ultimately, if 802.11 is the best solution for the market, and it was the best solution in terms of it was available, it was readily customizable, it took a lot less time to develop a refinement of 802.11 than develop something new from scratch. We might have developed something better new from scratch, but there's higher risk. So 802.11 is a good basis. Like most engineers, we shouldn't be always trying to invent something new. We should always try and look at, can we make this better? And then I think one of the things that 802.11 has taught us is we can make it fit for purpose. And currently, for ITS, 802.11p as it was, it's now just rolled into 802.11, is fit for purpose, and that's sufficient. We can always do better, but we shouldn't confuse perfection with good enough. And often we need good enough to make the things work, and good enough is always a good target. Don't spend lots of time trying to perfect things. Get it good enough so we can start to actually use it, then refine it in the market. That's why evolution is nice. Revolution is more risky. So let's evolve to the right place in the right time. Hopefully.
Okay, so then finally, thank you again for the presentation and also for the open discussion regarding the questions. I would give you the chance now to say some final words to the participants.
But as I say, I mean, I think my final slide is essentially what we need to do. We need to bring in multiple stakeholders to drive these complex markets. We have to accept it's a complex market, but we need to work together to do that, and we need to bring in more people, and we should also drive really hard for making transport of value to us as individuals, as societies, and not just to build better cars. Better cars don't make better transport. Better transport might make better cars. I think if we can take that from this and use standards to develop that, that'd be great. And I would just like to close by thanking you very much for the opportunity for you to, for me to spout a bit and for you to listen to my my angst and hopes and fears. Thank you.
So thank you. Then also thank you to the participants from my side for being with us today. Again, I wish you a good afternoon, good evening, wherever you are. And hopefully we see us again soon with one of our upcoming talks. Thank you. Goodbye.
Thank you. Bye-bye.